there are no convergence with the center sleigh.
Copy LD, can confirm no convergence with St. Nick. Reindeer not yet airborne for deliveries, and the North Pole is green for launch.
Understood. Go sequence complete. We are T-minus 11 minutes, 2 seconds and counting. We are call for terminal count auto sequence starting at T-minus 10 minutes from this time. The 3-word hold procedure is in effect.
That is confirmation from the LD, our operators, and the North Pole that we are go for today's launch attempt. Right now, the T0 is set for 3:17 NZT or 14:17 UTC. So today's launch is our 58th overall and our 16th mission for 2024, which beats our previous annual launch record of 10 missions that we achieved last year. Now, this mission is also taking place just 7 days after our most recent launch from LC2, which lifted off on the 14th of December and was our third launch from Virginia this year. So while it's not quite the 2 launches in 24 hours that we demonstrated last month, today's launch still represents a rapid turn between launches, especially from 2 different hemispheres. While launch often gets the attention, we are, of course, an end-to-end space company, so launch was just a part of what kept us busy this year. We also completed production of twin spacecraft for a NASA Mars mission. So snapshot of what kept us busy this year at Rocket Lab. What a year. And 2025 is shaping up to be even bigger across all of our programs. So if you want your next year to look just like that, why don't you join the team? Check out the career section of our website for all of the latest open roles. Before long, we'll hear today's launch director, Paula Teres Serralonga, count down from T minus 10 seconds. Now, just before we hit 0, all 9 3D printed Rutherford engines on Electron's first stage will ignite. And then 2 seconds later, the hold down clamps that keep Electron tethered to the launch mount, they'll release. And that frees Electron to take to the skies at exactly T0. Now, those engines will burn through the liquid oxygen and the kerosene stored in Electron's first stage until we reach depletion at around 2.5 minutes into flight. At that point, we're on the edge of space and we no longer need to carry the dead weight of the first stage with us. So we shut down those 9 Rutherford engines and the first and the second stages will separate. Electron's first stage will return to Earth, while the second stage, that is propelled by a single vacuum-optimized Rutherford engine, continues on to orbit, carrying the kick stage and its payload, the Strix satellite. At around 3.5 minutes into flight, the protective fairing covering the satellite will separate. From here, Strix will be exposed to space in preparation for deployment. The second stage has the longest burn time of all Electron stages, with that single Rutherford firing for almost 7 minutes to take us from the edge of space to orbital velocity. Along the way, we will conduct a maneuver unique to Electron called battery hot swap, but we'll go a bit more into detail once we're in flight. The second stage's job is complete around 9 minutes after liftoff. Its Rutherford engine will shut down just seconds before Electron's kick stage separates, carrying the Strix payload. The kick stage and its payload will coast around Earth for about 42 minutes before the small Curie engine on the stage ignites to maneuver into a circular orbit and deploy Strix to its new home in space. Before we get to liftoff, though, we have to enter what is known as the final count. So at T minus 2 minutes, Electron's flight computer will take over the countdown and autonomously run through final operations. Liquid oxygen will continue to flow into Electron all the way up until T minus 1 minute and 30 seconds. And then Electron's first and second stages will be fully pressurized and ready for launch. Now, with greens across the board and the launch operators go for launch, all that remains is to wait for completion of that final auto sequence, and then we are on our way to space. So let's listen in now to Mission Control.
The vehicle is 40 on internal power. IFTS is green, enable for flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Beginning pitch over.
Stage 1 propulsion is holding nominal.
Our 58th Electron is headed all the way up to space carrying a satellite for perspective. We are now 42 seconds into flight and we've cleared the pad, fast approaching max Q or maximum aerodynamic pressure, the moment in flight when Electron experiences its peak structural load. Now the guidance, navigation and control team monitors that milestone. So let's listen into mission control to hear their call out that we have cleared it.
Anchorage 7-2. HVB discharge is nominal.
Cleared max Q.
And just like that, Electron has successfully cleared max Q. We're now at 19.9 kilometers in altitude and traveling at over 2,800 kilometers an hour with those 9 Rutherford engines burning strong. Up next, in quick succession, we'll see main engine cutoff, or MECO, stage separation, and then second stage ignition. All 3 events take place within seconds. Electron's first stage will then return to Earth, while the second stage will continue the mission onto orbit. Let's listen in for those calls.
30 seconds.
$15 seconds to staging.
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
There we go. Successful MECO stage separation and second stage ignition confirmed. Now, Electron's vacuum optimized Rutherford engine will continue to burn for another 7 minutes from here, taking us all the way to orbit. And then up next is a milestone called fairing separation or fairing jettison. And this is where the 2 halves of the protective carbon composite fairing that covers the satellite on the way to orbit splits apart and falls away to expose the payload to space.
Fairing jettison succeeded.
There we have it. Fairing jettison has been successful. Now, Synspective's 6th satellite is exposed to space in preparation for deployment. Now, with just 5.5 minutes remaining in the second stage burn, we're at an altitude of over 127 kilometers. The second stage burn will be complete at around 9 minutes into the mission, so we have a few minutes remaining here yet. Now at T plus 4 minutes, 18 seconds into the mission, having just ticked over 10,000 kilometers per hour, we are above 163 kilometers from Earth and on our way to space with the second stage of Electron. Burning bright, as you
Stage
can
2
see
propulsion
there,
is still holding
coming up
nominal.
to our next milestone, which will be the battery hot swap. Our 58th Electron mission continues to track nominally 5 minutes into flight as we prepare for battery hot swap. The Rutherford engine's fuel is pumped electrically rather than fed by a traditional
Guidance
gas
is nominal.
turbine, and we
200
use
seconds
batteries to power those fuel pumps. Once we deplete one set of batteries, we jettison them and swap to a fresh batch to reduce mass on the way to orbit. Let's listen in for the battery hot swap call and keep your eyes peeled to see the silver glint on screen as they fall away.
HGB discharge nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Battery jettison confirmed.
Hot swap successful.
A fresh battery pack is now in place and battery hot swap has been successful. All that remains now is SECO, or second engine cutoff, when the Rutherford engine on Electron's second stage shuts down in preparation for kick stage separation. We're at 6 minutes into flight and that SECO is scheduled for just after 9 minutes, so just a few minutes to go.
Stage 2 propulsion holding nominal.
Electron's
PSI
second stage
staging.
engine nozzle continues to burn bright as we approach now T plus 7 minutes 22 seconds into the mission. The trajectory is on track and we are only a few minutes away from payload deployment. Now we'll hear a couple of callouts related to this. The first will be SECO for second engine cutoff to confirm that the Rutherford engine has stopped firing. And then next we will have the stage separation, and that will be confirmation that the third stage and its payload have been cleanly separated. T plus 8 minutes, and all is continuing healthy
Exit
and
burnout
nominal
detect
for
mode.
Electron. Keep an ear out for the call from the operators declaring that we've entered burnout detect mode. So that means that the Rutherford engine is throttling down ahead of SECO, officially completing Electron's journey
terminal,
to
20
orbit
seconds
before
remaining.
kick stage separation. You'll hear that call soon.
SECO confirmed.
Stage 3 separation confirmed. Nominal transfer orbit achieved.
Welcome to orbit. That's a successful shutdown of Electron's second stage, and the kick stage has cleanly separated as planned, carrying the Strix satellite on board.
The kick stage and Strix now enter a coast phase for around 42 minutes. And once they're at apogee, the kick stage's 3D printed Curie engine will ignite and complete the final leg of the mission, which is payload circularization and then payload deployment. So with that, we'll let the kick stage enjoy its tour around the world while we take a break, and we'll see you back here for payload deployment soon.